Hi guys, welcome back. Today we're tackling 2021 AMC 10A Problem 22. Hiram's algebra notes are 50 pages long and are printed on 25 sheets of paper. The first sheet contains pages 1 and 2. The second sheet contains pages 3 and 4, and so on. One day he leaves his notes on the table before leaving for lunch, and his roommate decides to borrow some pages from the middle of the notes. When Hiram comes back, he discovers that his roommate has taken a consecutive set of sheets from the notes, and that the average, the mean of the page numbers on all remaining sheets is exactly 19. How many sheets were borrowed? Let's first set this up. We know that the original sum of all the page numbers, which we'll write down as S0, is 1 plus 2 plus 3 all the way to plus 50, which is 50 times 51 over 2 is 1,275. We also know that right now, after Hiram's roommate borrowed some algebra notes, the mean of the page numbers that are remaining is 19. The mean is the sum of all the values divided by the number of values that exist. So the mean is 19, which means that the sum over the number of remaining pages is 19. What is the sum though? How do we represent this with variables instead of with words? Well, let's define A as the smallest page number that Hiram's roommate borrowed, and B as the largest page number that Hiram's roommate borrowed. The sum of the remaining pages would be from 1 to A minus 1. The first A minus 1 pages are still remaining. So 1 plus A minus 1 times A minus 1 over 2 plus the remaining pages from page B plus 1 to page 50. So from page B plus 1 to page 50. And from page B plus 1 to page 50, there are a total of 50 minus B plus 1 pages. Divide that by 2. So this fraction plus the other fraction I just wrote down is the sum of the page numbers remaining. Now we have to divide that by the number of pages remaining. The number of pages remaining would be 50 minus the number of pages borrowed. The number of pages borrowed is B minus A plus 1. So the number of pages remaining is 50 minus B minus A plus 1. Now, to get rid of the fractions, let's multiply both sides by 2 times 50 minus B minus A plus 1. On the left-hand side, we have 38 times 50 minus B plus A minus 1. On the right-hand side, we get rid of all the denominators. We can expand the expression and get A squared minus A minus B squared minus B plus 50 times 51, which is 2,550. After we expand the expression on the right-hand side and simplify everything on the left-hand side, and we move all the variables to the left-hand side and the numerical values to the right-hand side, we end up with negative 38b plus 38a minus a squared plus a plus b squared plus b. On the right-hand side, we have 2,550 minus 38 times 50, which is 5 times 8 is 40. So 1,940. It's 1,900 plus 38. Now we want to factorize the left-hand side because A and B are both integers. So if we factorize and we get brackets times brackets, then we can just factor whatever's on the right-hand side, which seems to be 650 plus 38. Then we can factorize this and then test out different cases. Let's first factorize B squared minus A squared. B squared minus A squared is B minus A times B plus A. Next, let's factorize this. 38a minus 38b. That's minus 38b minus a. Then we're left with a plus b, or b plus a. So the next step would be we have b minus a times b plus a minus 38 plus b plus a. To factorize b plus a, to make sure the left-hand side is factorized, we want to subtract 38 from both sides. And then now we have the factorized expression b minus a plus 1 times b plus a minus 38, which is 650. Now let's prime factorize 650. 650 is 2 times 5 squared times 13. Essentially 26 times 25. So let's test out different cases. What cases do we have? We have b minus a plus 1 is 13. So when b minus a plus 1 is 13, b minus a is 12. And then if b minus a plus 1 is 13, b plus a minus 38 must be 2 times 5 squared, which is 50. So b plus a is 50 plus 38, which is 88. If we solve this, we get that b is 50 and a is 38. Now this may seem right. However, since Hiram's notes are double-sided printed and a is the smallest number on all these sheets that Hiram's roommate borrowed, a should be odd. So this case does not stand. Let's also look at another case where b minus a plus 1 is 25. So b minus a would be 24. And b plus a minus 38 would be 2 times 13, which is 26. So b plus a is 26 plus 38, which is 64. Solving this, we get that b equals 44 and a equals 20, which is again incorrect because a has to be odd. Let's test out another case. What if b minus a plus 1 was 26? Then b minus a would be 25. And b plus a minus 38 would be 26. So b plus a minus 38, b plus a minus 38 would be 25. So b plus a is 25 plus 38, which is 63. Solving this, we get that b is once again 44, but this time a is 19. Since a is odd and both of these page numbers are in the range from 1 to 50 inclusive, this case works. Since there are 5 options and this is a single choice problem, there's likely only one case that works. So we're only going to move forwards based on this case. When a is 19 and b is 44, the number of pages that Hiram's roommate borrowed would be b minus a plus 1, which is 44 minus 19 plus 1, 44 minus 18, which is 26 pages. However, the problem asks for the number of sheets Hiram's roommate borrowed. So the number of sheets is the number of pages divided by 2, which is 13. The answer is therefore B. Thanks for watching. Remember to like and subscribe.